Hello guys, today in this video we are going to study about the electrical motors, its introduction. So let's start. So electrical motors have the different parts, okay? So you can see this is one of the motor, that is induction squirrel cage induction motor. You can see here is a terminal box, okay? And you can see the next part is the stator winding. Here is the stator winding and this is the rotor winding, and this one is the shaft, okay? This is the bearing, okay? This is the bearing, and this one is the rotor. This part is of rotor, okay? And then this is the end bell, okay? This is called as a end bell, okay? And this part is a stator. Yes, and this is the motor frame. This total part is motor frame. And here this again, this side there is a bearing also, and this is again other side in the bell, and this is cooling fan, okay, made up of aluminum. And this is the fan cover. This is the fan cover, okay? So let's see uh, what is meant by electrical motor. So electrical motor, it's an electrical machine, and that machine converts the electrical energy into the mechanical energy. Means whenever we give the AC or DC source of energy to that machine, electrical machine, okay, we are calling it as electrical machine. So at that time what happens, at the output side it will give us a mechanical energy, okay, and that is called as what? Electrical motor, okay? So the most electrical motors, they operates on the principle of generation of twisting force. Twisting force means what? The rotor rotates, okay? So it rotate means what? It gives the twisting force at the output side, okay? Or this twisting force, why this produces the twisting force? Because of the interaction between the magnetic field and the winding current of the motor, okay? So you can see the diagram and you can see the basic principle of that electrical motor. Now the classification of the motors. So electrical motors are broadly classified. This is depending upon the supply or energy, which type of energy we are using there, okay? Which type of supply we are using there, AC or DC. So DC motors and AC motors, this is depending upon the energy source we are using. So we can classify the electrical motors on the basis of the following parameters. So which are the parameters? These are AC DC power supply source, internal construction, how it will be, applications, then type of motion output, okay, means continuous output, steps output, etc. And then brushed and the brushless, number of phases, single phase motors or a three phase motor, okay? So electrical motors produces a linear or a rotary force. We can, means we will see in the next upcoming videos. So this is the classification, broader classification of electrical motors. So electrical motors are mainly classified into the DC motor, AC motor, and the special purpose motors, okay? So in a DC motor you can see there is a separately excited DC motor and there is a self excited DC motor, okay? So again, for self excited DC motors we have the shunt motor, series motor, and compound DC motor, okay? In AC motor we have induction, or also we can call it as a asynchronous motor. Again in AC there is a synchronous motor, okay? So in induction or asynchronous motor we have again a single phase and a polyphase induction motor. In a single phase we have the capacitor single phase induction motor, and we have the shaded pole single phase induction motor, okay? In a polyphase we have squirrel cage and a wound rotor, or also we can call it as a slip ring induction motor. And in a special purpose we have the stepper motor, hysteresis motor, reluctance motor, and the brushless motor, okay? So we will study the DC machine now, okay? So DC machines are of two types, okay, namely DC generators and DC motors. Yes, so DC generator, what it does, it converts the mechanical energy into the electrical energy. Whenever we give them the mechanical energy, it will give the electrical energy to us, Okay, so whereas a DC motor converts the electrical energy into the into the mechanical energy. Okay, means we use them the electrical energy and it will give us a mechanical energy. This is the work of DC motor. The prime mover supplies mechanical energy to the DC generator and which generates the electrical output energy. Okay, the motor accepts the energy in the electrical form, DC source, and converts it into the mechanical energy as its output. Means the at output means at a shaft it will give us a mechanical power, mechanical energy. In order to understand the operating principle of DC motor, it is necessary to understand how does a current carrying conductor experience a force when kept in a magnetic field. So I will tell you the basic principles of the motors. Okay, so mainly two principles are there: working principles or the basic principles of the motors and generators. So whenever we talking about the generators, at that time the principle using that is the Faraday's law of electromagnetic induction, and this is for what? Generators. Okay, and for the motors there is a Lorentz law. Okay, Lorentz law for motors. Now what is the Faraday's electromagnetic induction? Okay, so whenever we uh, put the conductor in a magnetic field, okay, either the rotation of magnetic field or the rotation of conductor, and EMF is induced in that conductor. This is the Faraday's first law of electromagnetic induction. And I was talking about the motor's principle. Motor principle is Lorentz law. Okay, it means Lorentz law is there. So Lorentz law is what? So whenever a current carrying conductor placed in a magnetic field, it experiences a mechanical force. That is what a Lorentz law. Okay, so now windings in a DC machine. So windings in a DC machines, in any DC machine there are two windings. One is a field winding and next one is a armature winding. Okay, these are the two windings you can see in this image as well. Okay, so out of these the field winding is a stationary, which is on the stator part. Okay, and which does not move at all. And the second winding is armature winding, which is a movable winding and which is placed on the rotor. Okay, so the armature winding is mounted on a shaft. So you can see here is the armature winding that is mounted on the shaft, so it can rotate freely. The construction of DC generator and DC motor is the same, means DC motor and DC generator is the same in case of construction. That means we can use the same DC machine as a generator or a motor. Okay, so this was the brief about the introduction of electrical machines. Now we will see the next portion of this part in the next video.